Welcome, please, to the What's New in Xamarin.Android talk. On the screen, thank you. No. Really, I don't deserve this. They do, please, but I don't. On the screen, we have Rodrigo Kumpera, we've got Jérémie Laval, and we have me. And side story, in case you've never heard it, at almost every conference that Jérémie goes to, they're never able to print out his badge properly. They always screw up the Unicode. But this year, they actually did it properly. And then they screwed up Boyons. So nobody's perfect, right? It is a minor miracle of Unicode and encoding. Right. So we are here to fill you in on the past and soon to be present of Xamarin.Android, Mono, and the Android Designer within Xamarin Studio. But first, let me tell you a secret. Really? That's the only response I get? Jeez. Android development drives me crazy. More or less like this. Yes, no, right. So why does Android development drive me crazy? Well, because when creating a new project to deploy to a new device, I always have to hit config property dinguses. It's just annoying. Tracing JNI global references is a major pain. Binding Java libraries is similarly painful, and a good fraction of the entire product is binding a gigantic Java library. So if the purpose of Xamarin is to delight developers, well, I can start with delighting myself, right? So let's address this with the What's New in Xamarin.Android portion of our presentation. So for starters, the last time I gave this talk was 18 months ago at the previous Evolve, and so a lot has happened and been released over that last 18 months. So what does that include? Well, for starters, that includes a rebased base class library framework atop .NET 4.5, which includes lots of async support, which everybody is using, and it's made all your apps much better, right? Right? Well, hopefully, yes, that would be good. It includes C#5 support, which also includes C#4, which means we have full dynamic support, assuming the linker doesn't remove what you're trying to use. But all right, we theoretically have C#4 dynamic support. We've got covariant interface support, covariant delegate support. We've got the C#5 caller member name attributes. We've got lots of really, really great stuff in the C# language. We have also added F# 3.1 support. And I'll let Larry O'Brien talk about that Friday. Is that when this talk is? I forget. Next up is System.Net.HTTP, which is a glorious async wrapper around the HTTP stack so that you can use even more async code in your code and go crazy when you're trying to read the stack traces when everything goes wrong. I mean, no, have perfectly responsive applications, right? Yes, responsive applications. That's the key here. We have Androids up through Android 4.4, which is API level 19. Paid no attention to the Google I/O in June where we had where and API-L. But API-L is beta, so I wouldn't want that in a stable product anyway, because if they change it, we don't want to change our stable bindings. So anyway, up through API 19, we have pickle and nougat support, if you like Miguel's pronunciations, or PCL and NuGet if you're everyone else. Presumably everyone else. We have OpenGL ES 3.0 support for all of your gaming needs. Does anybody use OpenGL for not games? Really? Wow. That's okay. Unexpected. Yay. Go you. And we have Android runtime support, which was nice in that it decided to break JNI weak reference handling, but we got that filed and they fixed it. So yay, everyone. So now we've got what we've done. Now what's coming? Well, what's coming is, well, after doing the 4.x series for the last 3 years, it's finally time to bump the major version number. And you know what bumping a major version number means? It means I can finally break your code. I mean, I can clean things up. Yes, I can finally clean things up. Yes, that's it exactly. Yeah, right. We're cleaning things up. So if anybody pays attention to the forums, which I'm sure some of you do, I asked about whether we can stop shipping API levels 4, 7, and 8, because at the moment, Android devices that are running less than API level 10 make up 0.7% of devices going to the Google Play Store. So why do we care? So we don't, and that saves space in the installer. Yay. And we don't need to build it anymore, but that's just good for me. This does not mean that your apps won't be able to run on those platforms. So your app will still be able to run on Android 1.4. Please tell me nobody is actually trying to run on Android 1.4. But if you need to, you can. But it just means that when you're in your IDE, the IDE code completion and the compiler won't tell you when you're trying to use a type and member that doesn't exist on Android 1.4. The lowest that you'll get code completion support for is API 10 Gingerbread. So, removing those. We are also removing Mono Android Google Maps, Mono Android support v4, and Mono Android support v13. We obsoleted every type in all of those assemblies in August. So if you've been using any of those assemblies, you've probably been getting a bazillion warnings or errors. If you do warn as error, please never do warn as error. No. And the reason for this is, well, they're obsolete. Google Maps was obsoleted by Google like 2 years ago. Google Play Services is the replacement and has been for an eternity at this point. Please use Google Play Services. Mono Android support v4 and v13 were binding an ancient version of the support library. If you want to use the support library, you presumably want the latest version, which is bound in the Xamarin.Android support component on the component store. Please use that instead. It's much, much better. We are changing the minSdkVersion behavior. So remember my minor rant earlier about how annoying it is to create a new project and deploy it to your random device. Well, this is because of the minSdkVersion behavior. Previously, the minSdkVersion, well, let me take a step back. What is the minSdkVersion? The minSdkVersion is an attribute within Android manifest.xml which controls the lowest API level that your application will run on. And by default, it is equal to your target framework version. And by default, the target framework version is set to the highest API level installed on your machine. So if you want to deploy to a device that isn't the highest API level installed on your machine, like, oh, you have API-L installed for the alpha, but you don't want to put API-L on your actual carry-around hardware device, that means every time you create a new project, you'd get this stupid warning saying, target device not supported, your application wants something higher. And that's not happy, that's annoying. So what we are doing is we are changing the behavior in 5.0 so that the default value is 11, unless your target framework version is set to 10, and then it gets set to 10. And the reason we set it to 11 is because that's the minimum required for activity bar to work. Otherwise, you get null pointer exceptions. So, as always, you can go to the project options. Actually, you should go to the project options, and you should override the minSdkVersion attribute. But for the default case, it'll be 11 for all sane targets. We are fixing cross-virtual machine exception propagation. Has anybody ever tried to throw an exception from C# and do something with Java on the caller's call stack? No? Good. Because it's bad. It's Yeah, we'll cover that in a bit. I am changing the framework version number scheme, pattern, whichever. So previously, the target framework version that you would see in your CS_proj file, if you ever looked at your CS_proj file, would mirror the Android version that we were binding. So for example, if you're targeting API 19, that's Android 4.4, so you would see v4.4 in your CS_proj for the target framework version. The problem with this scheme is it's not future-proof. Specifically, I know there's at least one bug that has been requested years ago that would require a major ABI break. Specifically, everyone's favorite, why do we have Java-lang object everywhere instead of just using system object? Why does view.tag not T an object? Why do I have to keep subclassing Java-lang object everywhere? This is a good question. We're not addressing it this year. But I want to get us set up to be able to address it, and in the process of addressing it, it will presumably be a major break. So since we know we're going to want to break things, theoretically anyway, what do you do if you want to advertise this to your clients? Well, there's this wonderful thing called semantic versioning at semver.org. Hopefully you've heard of it. It also happens to mirror the .NET version guidelines from before 1.0. And the basic idea is if you perform a breaking change, bump the major version number, and that lets all your clients know that things may have broken, you need to retest. So as part of the 5.0 migration, I'm going to be prefixing the previous Android version target with 5. So to target Android 4.4, the target framework version will be 5.4.4. This should impact, hopefully, almost nobody, because the IDE should handle it for you. It's just a drop-down toggle. But there were certain scenarios where, particularly on Windows with Visual Studio, you could add registry entries so that when you went to your assembly references dialog, it would show you additional assemblies that were compatible with the target framework version of the project that you were building against. And those assemblies won't show up now if you were making use of that. And that is deliberate. That's the whole point of having semantically useful version numbers. And this isn't in the alpha that we are releasing today. All the previous changes, breaking changes that I mentioned are in the alpha that is being released today, but ACW name changes isn't. But this is also an issue that has hit a number of people, which is that, well, here's the scenario, here's the bug report. At the moment, when you subclass Java-lang object and then you build the application, we generate Android callable wrappers for all those types. And to generate the name of the Android callable wrapper, we take your namespace name and we lowercase it, and then we use your type name, case unchanged. There you go. And so if you go into layout AXML files, sometimes to work around bugs, you'll need to use the ACW name instead of the actual name because we have bugs in our fix-up process. And so you might be using the ACW name either deliberately or inadvertently. Now, the problem with this wonderful approach is if you happen to have two assemblies that have the same namespace and the same type in that namespace that just happens to subclass Java-lang object, at which point your build blows up because you're trying to add two fully qualified types with the same name to the dex file, and the Android toolchain doesn't like that, reasonably so. And this has hit not a lot of people, but it's hit a few people, and it's virtually impossible to work around in your own code if you are using utility code and you don't want to have to change that utility code because then you need to track it in your source control, and nobody wants to do that. So what I'm currently working on for the final release is the type name will remain unchanged, but the package name for the Android callable wrapper will be based on the namespace name and the assembly qualified name of the assembly that it came from. So if it's coming from two different assemblies, with the same, even if they're from the same namespace, it'll be like the MD5 sum, and so they'll be pretty much unique unless you decide to break MD5, but really, who cares about that? Now, the workaround, if you do need to preserve names, is since forever we have supported the register attribute, which allows you to explicitly provide the Android callable wrapper name. And the activity and service and content resolver and broadcast receiver attributes also have a name property that allows you to set explicitly the Android callable wrapper name. So if you need to preserve compatibility, there are mechanisms to do so. And there will probably be an MS build property to disable this behavior. But the alternative is to say it's an opt-in feature, and then nobody's actually going to test their code against it. So when you actually test your code against it, it might break. And I think it's actually better to just make it the default. And hey, it's time for a major version change. And I probably should have mentioned this 10 years ago, but if anybody has any questions, please raise your hand, and I would love to answer them. And I really should have mentioned that at the beginning, but I forgot. So, sorry. So about those breaking changes, we have the minSdkVersion, which I think I already went over. But in the middle here, we've got the, wait, I've got a laser pointer. Here, we have the minimum Android version toggle drop down. And previously, you would have to possibly change that all the time, depending on what device you were deploying to. And I find that annoying, and so did lots of other people. So at least someone is rejoicing somewhere, hopefully. Yay? Yay. All right, so that's the minSdkVersion. Next is cross-VM exception propagation. So the real question is, what on earth does this mean? Before you tear your hair out, because I'm losing my hair. So what it means is consider this code. We've got some Java code. We have this invoke method that invokes the runnable.run method on the parameter within a try finally block so that it will do something if an exception occurs, or if it doesn't occur, invoke doesn't care. It just has it has cleanup code. You can imagine that this cleanup code is closing file resources or doing logging or any number of things that you would certainly expect to actually be invoked. And then we have a C# binding, not shown. We're using the binding, excuse me. And so we are using an action, wrapping the action in a runnable. So we create the action here. We wrap it in a runnable here. We invoke our Java method. And so the question is, what do we expect to happen? Because what I would expect to happen is we invoke our binding, which invokes the Java method, which invokes the parameter.run, which invokes runnable.run, which will invoke our action, which throws an invalid operation exception. Well, as it happens, we are within a try-catch block, and we have a catch invalid operation exception. So the exception should be thrown. We should hit the, I think I'm losing power on my laser pointer. Uh-oh. Well, anyway. So the exception should be thrown. We'll hit the finally block. The message will be printed. We'll re-enter managed code. We'll hit the catch block. We'll catch the exception. Life continues as normal. Everybody's happy, right? This is what we might expect to happen. What actually happens is your process dies a horrible, fiery, explodey, sig-seg-v-filled death. And I'm actually surprised there's not more bugs about this, but I guess nobody is actually throwing exceptions at cross VM boundaries. How fortunate for me. So we are finally attempting to resolve this. Yay. But in the process, there are a few semantic changes that are happening, particularly within the debugger. I really wish my laser pointer worked. No, I just needed to let it cool off, I guess. So the most visible issue is that if you're running within a debugger and you like to break on unhandled exceptions, I assume that will be a majority of you. So imagine, for the sake of argument, that instead of throwing invalid operation exception, it were to throw not supported exception, or some type that is not caught in managed code. Well, what you would expect to happen inside of a debugger is, all right, not supported is thrown. We exit out of the Java. Java executes its finally block. We get back in the managed code. We look for the catch block. It doesn't match. And we percolate up, and then we break unhandled exception. And it should give us the nice full stack trace of where the exception was thrown so that we can see what the context of the exception was. Yay us, we can actually fix the bug because we were in a debugger in the first place. Where is the debugger going to break us on? Where we want to break is here. At this point in time, it will break here because that's how the exception marshalling works at the moment. This is something that we plan on fixing or attempting to improve, but at the moment, them's the breaks, and at least you're not having a terrible SIG-SEG V-filled death. There is a way to disable the new cross-VM exception propagation behavior. There's an environment variable, which I believe is documented in the release notes, I hope. Somebody tell me if I'm wrong about that, but you can see the release notes, which will get you back to the previous behavior. But again, in the previous behavior, if you happen to cross VM boundaries, you're going to die. So we're kind of caught between a rock and a hard place, but this behavior is better, in my not-so-humble opinion. So that's the cleanup and the breaking changes. So what nice, wonderful new things can we expect in Xamarin.Android 5? What's our new hotness? Am I pronouncing that right? Maybe. This is a tough crowd. I can't get a single laugh out of you. Jeez. All right. Oops, too far. So we are going to be providing Android L bindings for stable. So what this by definition means is we are not seeing Xamarin.Android 5 in stable until after API L is stable from Google. So that gives you a minimum time frame. But yeah, I'm guessing end of month, maybe. Who knows? We'll find out when API L is actually released for real. And while we did announce same-day support for Android Wear support, the actual inclusion of the Wear app in the handset app left a bit much to be desired. We are working on automating that to make it easier so that you can just add a project reference for your Wear app to your handset app, and it'll get automatically included and signed, and everything's good. We are bumping OpenTK to include support for OpenGL ES 3.1. Yay, for all the 5 beta hardware devices that actually support GLES 3.1. Maybe the next Nexus device will support it. We are working on a System.Drawing Nuget package for all of your 2D drawing needs. We'll hit a code example in a couple slides. My favorite feature, which I will expand upon later, is class-parse, which we'll expound upon later. I want to keep you confused for now. And we also have a new tool, logcat-parse, because gref logging is a royal pain, and nobody wants to deal with it. So I wrote a tool to help deal with it, and we'll do a demo of that later. So next up is System.Drawing. What we are doing is the bait-and-switch PCL tactic. Everybody's favorite. Xamarin Forms uses it. So we will have a Common Core PCL assembly that gives you just the normal System.Drawing. And then there will also be platform-specific extensions. For example, here we have Graphics Android from Android Surface, just to glue things together. But aside from the gluing things together, everything else should be more or less bog standard System.Drawing semantics for everybody who actually wants to use System.Drawing. I don't know. I don't do lots of drawing. So class-parse. Class-parse is so if anybody was at my Android Java bindings talk at the last Evolve, you may remember, I should have copied the slide. Binding is a three-step process. You take your jar, you run it through a tool called jar.xml, and you get an XML API description, which is maddening to read. Then you take your API description and run it through fixup with metadata.xml and throw it at generator, which generates a blob of C# code. And then you can add partial C# classes to that C# code, compile the whole thing, and wind up with a binding assembly. Everybody's happy, right? Except for all the things that are wrong in the jar.xml step and the generator step, but one thing at a time. So, what is one of the issues that we have encountered is this example Java code. So we have a public class C that happens to have two methods, which we'll meet again, but we have a package private class P. And so we use our package private type as a parameter on one of the methods. Why Java allows this, I don't know, but you could not do this in C#. You can't use an internal type on a public method on a public type in C# because the assembly visibility rules prevent it, because it's stupid to do this. I mean, yes. So it is not an uncommon scenario. Well, all right, it's come up a few times anyway. So what happens when jar.xml attempts to parse this? Well, first, a step back. What does jar.xml do? Jar.xml is a Java app that runs within a Java VM and uses the Java reflection APIs to list out all of the methods that are on the Java type. So implicit in this operational semantic is that all of the types that are used are available in class path so that the JVM can resolve them. The problem is some vendors have libraries like this where they have a public type with a public method that takes a package private type as a parameter, and they don't ship the package private types, which means Java, when it's running, can't resolve the package private types, which means when you run it through jar.xml, you might get the class name, but that's it. You're not going to get any of the members on it. There's no methods. There's no constructors. I don't think you get fields, but I don't remember offhand. Doesn't matter because a type is worthless if you don't have the methods anyway. It's a worthless shell of an API description. And the whole reason we have this problem is because we're using Java reflection to determine what the API description is. So eventually I get annoyed. And when I get annoyed, I unfortunately start writing code. The applications written in anger are the best ones, right? Maybe. And so over the summer, I said, well, really, how hard could it be to read the Java class file format? So I wrote one in C#. Dean's fixing it up now, but proof of concept, you know. And as it turns out, the Java class file format is not bad. It's reasonably straightforward. Reading through the spec made me better understand why they went with Java type erasure instead of reified generics. I still don't like type erasure, but never mind that. But I also found something else in the process. A long-standing issue, complaint, limitation is parameter names. Whenever you run Java P, whenever you run jar.xml, whenever you run any Java tool, you have no access to parameter names, which is why we keep generating these dumbass P0, P1, P whatever parameter names that absolutely nobody likes. As it happens, if the Java code is compiled with debug information, it does contain parameter names for non-abstract methods. And as it happens, Android.jar, at least, contains debug symbol information, which was really nice. I don't know how many other Java libraries actually also contain debug information, but if at least some of them do, we're already way, way better. So as a result of the fact that we are now manually parsing bytecode without involving a Java VM, and because we can look at debug symbols, when we use class-parse, we can get the class name, we can find the constructor, we can find the method, all the methods, and, well, I was running out of space, but you will also get the parameter names for non-abstract methods. And then Dean went one further, and so abstract methods don't have a method body, and so that makes it hard to contain the debug symbol information for parameters. This is also true for interfaces. So we'll look through all known classes to see if any of them inherit from the abstract classes or inherit the interface so that we can deduce the parameter names for the abstract methods. That's awesome. I like it. I like it. This, unfortunately, is not yet hooked up to Android Java binding projects in the alpha we're releasing today, but I hope to be able to have it there so that you can at least opt in or opt out. We need to figure that out. But it will be present in the final 5.0 project, and I'm so happy to have that. Next, logcat parse. Read the subtext. Man, I can't even get a groan out of you. It's a good thing I'm not a stand-up comic, you know? So grefs and the grief they cause. Well, we've had gref logging for years. I forget when we added that, probably in one of the previews. Actually, almost certainly in one of the previews. And initially, yay, we had output. Unfortunately, it was truncated because we were sending the entire string as one string to one of the Android log functions, which had a limit of 1,000 characters. So you would invariably get your stack trace truncated after about 5 lines, which was really annoying. Finally got that one fixed in 4.14 over the summer, which is why when you look at this wonderful +G message, it actually takes up most of the screen. But hey, we're getting the full stack trace now. Yay. But of course, this is gigantic. Nobody really wants to read this manually. I mean, you will if you have to. Or if you're just running the app for damn, I'm drawing a blank on what killed the cat. Curiosity, yes. If you're just curious, you can always look at the gref count value to let you know how many grefs you've actually allocated, which is frequently a very useful thing to do. But if you're doing anything more than that, reading this output it will drive you insane. So we have a new tool called logcat parse, which I will demonstrate to you now while also muttering to myself. All right, so, oh, well, let's come over here then. So we will fire up Xamarin Studio, and then for good measure, because nobody likes to wait, I'll fire up, if I can type Xamarin.Android player. We announced that, right? I'm not breaking anything? I don't think I'm breaking anything. Yay, Android player. All right, so I will open up my test project. And so here's an example, when we load, of why you would care about grefs. Did anybody go to the Android Performance talk yesterday as part of training? Okay, that's a good number. How many of you actually still use emulators? Right, okay, yeah, even better. So if you missed the performance talk yesterday, one of the discussions, no, I don't need to update right now. One of the discussions was that there are 2 virtual machines within the process. We've got the mono process, we've got the Dalvik process, or the ART process, or whatever they're calling it this week. We'll just call it the Java process. And where did I put my water? When you create, say, a bitmap instance, what mono sees is this nice, small, what was it, an 80-byte value? I forget what the actual count was, but a reasonably small value, which may be pointing to something gigantic in the Java VM, which bloats your memory use and memory requirements and makes everybody sad. And the problem is that you need to know that, say, a bitmap or something like that is consuming or potentially consuming lots of Java side memory. And so the question is, how do I reasonably do that? So let us consider this terrible sample app that I drew up. So what we do is we've got 3 buttons. I know they're buttons because I have click events. Actually, no, I know they're buttons because I wrote it. Anyway, so what this does is it calls show image, which calls resources drawable, get drawable. How readable is that? I should probably bump up that font size. Okay, we'll just use we'll just do that. That's better. Okay, yeah, that looks readable, I hope. So we call show image, which calls resources.get drawable. So this allocates a Java side drawable instance for the specified resource ID. We show it on the screen, and then we call leak memory. Can you guess where this is going? So what leak memory does is it adds it to a C# side list. And what this means is that the drawable that resources get drawable return to us can't be collected by the GC because it's actually being referenced. And it's a strong reference, and so it can't be collected until this entire activity is destroyed, which in this app will never happen because it's the only activity until you exit it entirely. So, I need to go back out. All right, so there's my Android player. All right, and then I hit play. And I forgot to do something. Can anybody guess what I forgot to do? No, because I'm not on a script. Maybe I should get a script some here. Oh, zip a line, installing the platform frame. I really should have installed that before now. Oh well. So I'll tell you what I forgot to do. What I forgot to do was actually enable gref logging. I mean, the whole point of this demo is to show you the grefs. But yeah, we've got the application output here, and then we can show a nice small image, or we can show a larger image. I love this image. Or we can show a gigantic image, which actually shows off a bug of Xamarin.Android Player, which is an issue with all simulators, which is it's not hardware. When I ran this on my Nexus 5, every time I hit show gigantic, it would blow up with an out of memory error. But Xamarin.Android Player has access to all your system RAM. So click, 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 click. As always, you need to test on hardware. You always, always, always need to test on hardware. This is good for development, but it's not hardware. Make sure you test on hardware. Anyway, so we click the button a lot, and we have no use at all here. So the question is, I want my grefs so that I know how bad I'm doing. How do I get it? So what you can do is, if you're on Mac, Windows is somewhere else. Where is that? Android, SDK, Mac x86. I can't remember because I have it in my path. ADB. All right. There we are. So in Platform Tools, I should bump up the font size here. Right. So in Platform Tools, we have ADB. So what we can do is we can do ADB shell set prop debug.mono.log gref. This enables gref logging for anybody who's read my forum posts over the last 3 years or actually read the documentation. Does anybody care? So now that we have gref logging, we'll go back to here, stop, restart our app. App launches, and now we see that we are now spamming the application output window. And at the time of loading, we have 15 grefs. All right, fine. So let's show the buttons. Let's show a bigger one. And if we look here in the application output, we see we're up to 28 grefs. Wow. Let's show a gigantic one. Whatever. So if we were actually trying to run the, I wonder if the Android DDMS connects to Android Player. Never tried that. But if we were looking at the Android memory tools, what we would see is that our memory use has exploded. But we're concerned in this particular discussion about grefs. So what we can do is we can do adb logcat, which I'll redirect to a file. And then to make sure that's actually correct, I should have done this. Oh, wait, it goes all the way back to the beginning of time. So what we have is library, frameworks, Xamarin.Android, commands. We have logcat parse, which is a command line tool because I like the command line. And what we also have is an interesting confluence of different teams going in the same general direction without realizing it. So what logcat parse does is it's a C# REPL. So what it does is it parses the log file. This is more for letting you know so that you can redo it later. But what it does is it gives you an object model over the contents of the logcat output for grefs in this particular case. So we can ask, how many alive peers are there? 29. How many peers have we allocated? 31. All right. Now, the more useful one is, what is consuming my grefs? Now, imagine you have a large app and you have, say, 500 grefs. It would be useful to know what the low-hanging fruit is. Well, we can use the grefs.getAlive JNI type counts method, which returns a dictionary of JNI name to count of how many there are. So, encoded handler is part of cross-VM exception propagation. Who cares? So here's your main activity, of which we've only created one. Here's the 3 buttons that we allocated in order to subscribe to the click handler. Here are 3 on-click listener implementers, which are used to implement the click event handler, and there's 3 of those. Minor note, if you are trying to reduce gref use, each event handler winds up pulling a gref. If grefs are an issue, and occasionally they are, you may want to manually implement the listener interface yourself so that you can share the same listener across multiple buttons. There's resources, but the more important one is we have 9 instances of bitmap drawable. And so now we can know, because we've been working with Android for years, that if you see bitmap or you see drawable, or any number of a set of types that you know tend to be small in the mono side and possibly gigantic in the Java side, you can say, oh, that looks bad. And you were able to see this without needing to read screen upon screen upon screen of logcat output. So that's good. So then we can do get distinct stacks for JNI type. So we can copy our JNI type. And so, well, there's a bunch of almost unreadable stack traces, but what's particularly useful in this one is we have show image and get drawable. So by knowing our code and looking at the stack trace, we can know that this is where it came from. Sorry, it's not easier to read, but it's something. And because this is the C# REPL, we have System.Link, so we can do such things as allocated peers, sorry, that's a property, where p dot what's in there, where handles count is greater than 1. I don't know what that actually means, but that gives you a list of the peers that actually do it. And for each peer, we have a toString that prints out a bunch of information, such as whether it's been collected by the garbage collector, whether it's been explicitly disposed, whether actually collected is whether disposed or finalized. So was it explicitly disposed or was it finalized by the garbage collector? The JNI type, the C# type, the key handle, the number of handles that we have created for this bitmap drawable. I wonder why it's 2. Anyway, no matter. So hopefully this will help you in investigating the logcat output and hopefully preserve a bit more hair on your head. If you have any suggestions for future improvements, And I really need to talk to the unit test team about how to do syntax coloring, because that never even occurred to me. Please send me an email or file a bug for a feature request in logcat parse. With that out of the way, we now come to the demo's over. We now have Rodrigo here to tell us about what's new in Mono.
Great. I think it's off. Is everyone listening to me? All right. OK, perfect. Just before I start, let me take a picture here. This is really awesome. Huge audience. Taking a picture. This is so many people. And send to mom. Yeah, so I'm here today to talk about what we've been doing in the Mono runtime and how this is going to how this particularly helps Android. First thing is, we started with 3.0.10, and now we're at 3.10.0. And we did a little more than just shift to 10. What we did on this past year, we did, previous thing here, we did almost 5,000 commits. This is a ginormous amount of work. About a little bit over 12 months. This is hundreds of commits a month. This is a lot of stuff going in. And our community has been growing a lot, which meant that the Mono runtime got over 100 community contributors. If anyone ever told you that Mono is going away, quite the other way around. We've never been so healthy as a community. But what we really decided to focus on the last 12 months was performance. We went all the way to see where we revisit our whole stack on where things were slow and where things were good. And we decided to work on a lot of key aspects there. And because we did a lot of performance work in the past, but those applications no longer match what the reality of new applications are today. What we have today is a much different world. And IronPython is a good example of that. It is a benchmark that is incredibly hard to beat because it deals with a lot of small things. IronPython is an implementation of the Python language for the Mono runtime. And I really don't expect anyone to be running Python on your phones, on your apps. But IronPython highlights a lot of the very challenging things we do, like applications do. They do a lot of reflection. They're very dynamic. They do a lot of delegates. They're very dynamic. It allocates memory like crazy. So getting performance improvements there is very, very, very hard. And this highlights what we got between all two releases. Between Mono 3.6.0 and 3.8.0, which is about what we did in August, we got a 5% boost there. And this took a lot of engineering power because we spent years in the past optimizing for that, when the DLR was a big thing. And this will translate directly into improvements in your code. But IronPython is kind of the thing of the past. The other thing we did is we started to look at what all the applications are doing now. And something that is it's becoming very common, which is async. We found out that async is not getting all the performance, all the love that we could get. So we just decided to revisit all code paths that goes into async, and we decided to invest a lot in performance there. Async has a very particular difference from all the previous benchmarks and previous workloads we tested, in that every time you call await, you create a new delegate. And these delegates will be invoked a single time, which was really odd. In the past, we were writing WinForms app or ASP.NET apps. Those are the kinds of things that we were optimizing for. And for those, the delegates would usually be called many times. So we never really cared much about performance for invoking a delegate just once. So we got our things together, and that's what we did here. The first one, the one on the left, it's the static dispatch case. This is when you create a delegate to a method that is not virtual, which is a much simpler case. We had a lot of work in the past, but we're not great if your delegate was being called once. And from the same release, which was 3.6 to 3.8, we got sometimes a three times performance boost there. This will translate directly into async being faster. in your binding frameworks being faster. And then on the other side, on the right side, we have an even greater result, which are for virtual delegates. It's not the delegate's virtual, it's the target is virtual. When you create a delegate that targets a virtual function, we have to, at runtime, figure out what you're calling. We can't do that at compilation time. And this meant that we had to take a very slow code path for sake of correctness. But now we invested now to make sure that we can take fast paths and make sure that the first time and usually the only time you invoke a delegate, and for a virtual method, we execute really, really fast. We did some very low-level tricks there, and performance, it's about 20 to 30 times faster. It is amazing, the difference. If you have a very async heavy workload where you have a high churn, you're going to see that you have seen this difference. And it's not just your application that's getting the benefit, because the whole Xamarin.Android framework, it uses delegates over the place for its binding. It will help in general. If every single method you're invoking usually goes through 1 or 2 delegates, and that will translate into performance improvement. It will be significant. The other thing we worked on is the GC bridge. How many of you here are familiar with what the GC bridge is? Okay. A few that are familiar, you're familiar because it's a good thing or because you hate it, because you have always problems with it. And the GC bridge always shows up on logs, and people complain because it's slow and it's problematic. So to understand the GC bridge, I have to tell you about the 2 garbage collectors that we have. Garbage collectors are some very, very selfish beasts. They're really hungry for resources. They want all the memory on the system board for themselves. They want all the CPU. And if there's something that they really hate, it's about sharing. Garbage collectors hate sharing resources with anyone. On Android, but then on Android, on our product, we have 2 garbage collectors. We have Dalvik, and we have Mono. And they have to play together. So it's a very tense situation, because they're always, all the time, fighting for who's going to get the chance to run, and they need to work together to make sure that those objects that must exist on both sides, function correctly. They're not collected on one side, and they're still there, and half of it is gone, and vice versa. I think that, so they're all the time fighting. It's a very tense situation. It's really like they're always, pointing guns at each other, and we used to joke with a project we had before that if we had 1 extra garbage collector, it would be a Mexican standoff. And we never got there around. So the only way to make them work together is with something that is what we call the GC bridge, which is kind of like Tom Hagen, which is from Godfather. I hope you guys all get that reference. Tom Hagen's the consigliere. He's the guy that gets everyone sit together, let them vent, and then you say, well, here's what we're going to do. Let me make you a proposition that you're not going to refuse. And we always have historically a lot of performance problems with the bridge, because it is a very convoluted process. We have to move around lots of information about what objects are important for Mono, what objects are important for Dalvik, and so on. And we decided that we had to do something there. So we implemented 2 new flavors, 2 new bridges. The first one we have here is what we call old, which is what you all guys are using now. It's not a very clever name, and that's my fault, because I really suck at it. And we decided to keep the old bridge for sake of correctness, so you guys don't have to use something that is new, that isn't stable, that isn't tested for such a critical part of your application. So we'll always have something that will be stable and be working. After that, we have new, which is just like old, but with a lot of optimization on top. We keep the same core algorithm, which is something which is based on the Corasaggio algorithm. And we add a lot of optimization. We fix a lot of performance bugs we have there. But in the process of doing that, we figure out that we we should try try another algorithm that solves the same problem, the Targent one. And it actually got us some interesting results. So we decided to offer those two for you. And the first thing you'll notice when we get to performance there is that it is significantly better. The first one, the first test, which is on the left, random graph order 2, it's a very simple benchmark. We get like thousands of objects, and we randomly connect them. We just make a mess of it's like an object spaghetti, if I may. And we let the bridges run. And you see here, the old bridge, pretty slow. The bars tells you the time in seconds. So first bridge, the old bridge, and with the larger workload, it takes 4.5 seconds. The new and the Targent bridges, they barely hit in like 500 milliseconds. So it's significantly faster. We had customers with 10 to 20x performance improvements. But it's not just about being faster. As you can see on the other one, which is the inverse fan, which is a benchmark where we create a ton of objects and make all of them point to a single one. We can see that the old bridge, we found a performance bug where when you're increasing this number of incoming references, things would explode, the performance would explode. We fixed that, and you can see that now everything is linear. There's no performance degradation for having this kind of very connected object graph. And here now we can see that there's another interesting aspect. The first one on the linked fan, which is just like the other, but inside out. So we have one object that points to every single thing. You can see that, well, Targent's still faster than the old and new. And so it seems it's faster. But if you look at the other one, which is the double fan, which is when pretty much we have it's kind of a weird linked list where everything points inside out. Inside one object, and this object points inside out. The Targent bridge becomes slower than new. So we have this balance where some benchmarks new is faster and some benchmarks Targent is faster. And we kind of understand why this happens, but the thing that we could never figure out, and I think it's extremely hard, is figure out which one of those two your application is more like to be. Is my application, you're probably asking, is my application more like a linked fan or a double fan? So I can pick which one I should. And it's actually, it's probably as hard as the bridge itself to figure out which one is more appropriate. So the way to do it is usually you just go and try both and see which one performs better. And well, I guess right now you're asking, so how do I enable it? First thing you do is you pick your project, and you go there, you add a file called environment, and you set the build action to Android environment, which then you set the environment property. We have a great documentation on this. It's called mono_gc_params, and it equals gc-bridge and equals to old, new, Targent, which begs the question, why the hell we use so many environmental properties, right? Come on, it's this funky thing that you saw on John's presentation to enable log parsing. We saw now we're doing that. And it comes from, I don't know, for our Unix background where everything is env-prop. So, and it has the advantage that allows us to push new experimental features much faster without having to force the IDE people to, I don't know, make the advanced panel having, I don't know, 2,000 toggles. Because a lot of those features are not meant to be like available for general consumption. We want to just experiment as we see people having issues. It would be really great if you guys tried it. We are really excited with the performance numbers we're getting there. And we eventually want to get rid of OAT. So even if you're not really having performance problems with the GC, it would be good if you could try it and give us feedback if it's working or not, especially if it's not working. We really like to hear about bugs, even if it's the only thing we hear sometimes. And with that, now we have Jérémie. He's going to talk a lot about what's new on Xamarin Studio. Come on, Jérémie.
All right, so can we switch over to the demo machine? So I know you guys are probably hungry at this stage. We're going to run over a little bit, so I'm going to try to keep it short and sweet. All right, so I'm going to talk about the designer. So the designer is our visual designer for Android. So this is both on Xamarin Studio and Visual Studio. I'm going to demo here on Xamarin Studio, but this is equally available on Visual Studio. So this is basically a couple of the new features we have been cooking on for the past year. They're not in the product right now, but they're going to come as time goes into releases, so keep watch on that. So here, I'm using our Xamarin Store app. I see a couple of C# t-shirts in the audience, but for those who don't know, this is an app that you can download, and when you run on device, you can order a free t-shirt like this one. So this is really cool. I even hear that we have an F# version, so if you like to talk in pattern matching, monads, those weird things like that, you can also have an F# t-shirt. So here I've opened the main layout file, and I'm going to switch over directly to the source mode. So as an Android developer myself, I often find myself going into this mode when I need to really tweak my layout and when basically the graphical nature of the other view kind of gets in the way. And when I know precisely what I want, I kind of find it easier to go in there. So this is an area that we hadn't really worked on before. But at the same time, when you use an IDE, especially a modern IDE like Xamarin Studio or Visual Studio, you kind of expect some feature from those kind of code views. And I think the main feature, and a feature that we actually get requested a lot, is auto-completion. And so I'm happy to say that in the future, we will now support auto-completion also on layout XML files. So this is smart auto-completion. You get auto-completion for both attribute names, attribute values, elements, etc. You get a full-blown access to documentation, which type of value does attributes, for instance, here request. So if I go ahead and basically want to add, for instance, a background, if I type background, I'm going to see that my background, of course, accepts either a reference, which could be a reference to a drawable, to a bitmap, or directly a color. So if I go ahead and declare a value, since the system is smart enough to detect that I want either a reference or color, it's going to search for both the framework and your project for all the available resources that are compatible with it. So for instance here, and also because this is a color, I'm able to also show directly a preview. So for instance, I know that since it's a Xamarin app and we have our own design guidelines, we also have a couple of colors that are specific to us. So if I start tapping Xamarin here, exactly, I get all the colors that are defined. And so as you can see, I get a precise preview of what the color is going to be mapped then onto the device when you run the application. So here, since the colors are kind of well named, I know that blue is probably going to be some kind of blue. This is not too useful, but often if you use something like a list view item, let's say list view item background dark, you probably have no idea what it's going to map to in the end. So if I go ahead and add it here, so not only I can see it when I type it, when I'm editing the file, but imagine I come back to this layout later, and I kind of have forgotten what the color was about, then I can always just bring my mouse here, and if I hover over it, I'm going to get also a preview of what this is about. So this is going to work for colors, this is going to work for bitmaps. And also a very interesting aspect here, if you look at the bottom part of the preview, not only are we showing you a preview of what the drawable is going to be, but we're also going to show you how the Android resource system is going to resolve that value to the final thing that you're going to see on the screen. So here, this is not too interesting because the color that I have is directly mapping to a color reference. But if you use something like theme attributes or very complicated other resources that are available in the Android framework, usually they go through several steps. So here what we're going to show you is that we're going to go from the start, so the value that you just typed into your value parameter, and then we're going to resolve and show you exactly the resolve chain of this value all the way down to the actual value that you're going to see on screen. So this is very useful if you want to debug. And for instance, if you have not selected the right theme, it's very easy to see that the color is not being resolved, a theme color is not being resolved to the right value you expect. All right, so this is it for our editor. So let me switch back here to our main content view. So we always had support for showing a custom theme. And so this app also uses a custom theme that we have developed using Xamarin theme and colors. And so this is very useful, especially I'm a visual guy too at the same time. So I want to see exactly what my changes are going to affect, or my changes are going to affect my UI without having to deploy, obviously, my project to the device all the time. And this is especially important when you tweak system features like here, in our case, the action bar. For those who don't, the action bar is this thing at the top of here. And so we have done a couple of customization here. Obviously, in our theme, we have changed the color. We have enabled some system-level feature. But if you're familiar with action bar, and especially if you have run the app, you know this is not the only things you can tweak in an action bar. An action bar can have titles, can have different elements, but notably can have what we call action bar icons and buttons. And if you have run the app before, there is actually, when you run it, there's actually here an icon that directs you to the basket and the cart, where all the items that you have added to your list are shown. But until now, we were not able to display that because this is an information that is not stored directly into the layout, but that is stored into another file, a file called menu.xml. So now we are actually adding support for directly referencing those files. And so when I click here, the system is actually going to grab that menu, parse it, and see the icon and all the description, and then inject that back into our design surface. So you see right away, especially if you design your own icons, or if you have a designer with you, you're going to see right away how your icon look in the final result. So Action Bar also has a couple of different navigation mode, and this is also very useful if you have so we don't use that in our app, but if I were, for instance, to use tabs in my app as a navigation mode, tabs are also something you can customize. So we are also adding support for displaying all those different navigation modes. So you can switch here. You see here I'm switching between list mode and tab mode for this application. So this is purely design time. This is not enabling anything. This is just for you to see what your theming and what your color changes are going to affect. All right. So I just talked about the basket, the cart. So let's take a closer look at it. I have the XML, the layout XML here. So if you have done list programming before with Android, you know there is a couple of classes that you usually use, like list fragment or list activity. And those two classes have in common that they allow you to customize the layout that is displayed in EN. And so the way this is usually done is that you have two elements. You have a list view, which is where the elements are going to go. And then you have what is called an empty layout. So the empty layout is automatically picked up by the system and is displayed when there is no item in the list view. Because when there is no item in the list view, then everything is transparent, so the user sees nothing. So instead of having that, this system gives you the ability to display, like here, a friendly message to say, hey, your basket is empty, and this is free stuff, so you probably want to go back and add it. But when you're designing things, so the system handles that for you at runtime. But when you're designing a UI like this, there is a problem here because I have now this empty view that is standing on top of my list view, so I can't actually design my list view or my normal part without having this in my face. But at the same time, so of course, I could just go into the property panel, and there is a visibility property for that. So I could just go and hide this element from my view and just then start tweaking my list view. But I'm also maybe a very careful person. I'm not exactly sure if I change this visibility attribute. Maybe Android doesn't like that. Maybe it's actually going to blow up at runtime and not do what you think it does. So what would be very interesting is if I was able to hide this thing without, just at design time, without impacting anything on my app when it's running. So that's exactly what we're having. And if I select here my empty layout, we actually have now a new section here in the widget category, which is called design time. So what we're going to do here is that we're going to pick up some interesting attributes. In this case, we have visibility. And when you set that value, it's going to override anything else that you have declared before, but only at design time. And this is very important. So when you set a value here, what you see on the surface, and I'm going to go ahead here and make this thing invisible, when you see on the design surface, the whole thing disappears. But what's important is that when you deploy your application, we create an APK, or anything that runs on device or on emulator, this value is never going to be carried over. It's actually not even be carried over, but it's not even going to be in any of your layout XML or any of your Android manifest compile resource. You won't even see it there. So this is purely a change that is used just at design time in our designer. So now this is great. I don't have this empty layout in my face anymore. I can actually go and tweak my list view. And so we have our custom list item, which is also a different type of layout. So this is great here because I can, if I went in, I can tweak exactly how my list items are going to look like. I can have the right thing. But still, this is not perfect because although I can do it here, I would really love to see it directly in my list view here. Because you can as much tweak as you want, as much one single individual cell. But you may want to see also in action if you want to tweak the paddings, if you want to tweak the margins between elements and stuff like that. So now, the same design time attributes that I talked about, we're also adding a couple of new ones on things like list view here or adaptive view and all those kind of guys. And if you see here, I have a couple of new properties called list item, list header, and list footer. And this is exactly what it implies. So what you can be able to do here is that you're able now to set layouts. And so the same way that we did with action bar, this system is going to be smart enough to find them, follow them, and then include them directly dynamically in the layout surface. So if I go ahead here and put my the list item that I previously showed you, and click OK here, what you see now is that we're going to take that list item and we're going to try to pick inside, see exactly what type of view you have in, like text view, image view, and those kind of things. And then we're going to make a fake adapter that goes with it. And then we're going to populate that list for you. So that here, right away, I can see exactly all my paddings, my margin kind of work together and make a pleasant experience. Again, without having to deploy your application. So this is another improvement we made. All right, so just the last part I want to cover. So recently, I've actually added, I love Android Wear. I got myself a couple of those little guy. And so for those who don't know, Android Wear is Google basically take on wearables. So this is Watch. This is going to be in the future also Google Glass. If you're interested, as was said in the keynote, my colleague Chris Hardy is actually going to do a session of those. So you can use Xamarin to also deploy on those kind of devices. And so Android Wear is pretty much the same as an Android, the same kind of flavor than the Android that you have on your phone. You have the same base XML layout system. And so, of course, you would love to be able to design those layouts directly in our IDE. So we are also adding support as part of that for Wear. And so I recently made a Wear equivalent of our Xamarin Store app. And so if I double-click on the layout here, so when you use a Wear project, we're going to select the right type of theme because the theme on the device has like much smaller font. It has, as you can see, no status bar. It has a couple of like system-wide features that are interesting that are hidden away. So we simulate that and we show you the exact way this is going to look on device. And this is especially important because Android Wears come in two flavors. It comes, in this case, a square flavor, but it also comes in a round flavor. And with the round flavor, the problem is that it tends to clip your UI, which is a huge problem. So directly in the designer, we're adding support for that. You're going to also be able to not only see it in a square fashion, but you will also be able to see it in a round fashion. So in that case, with this layout, I know exactly that I have no problem, nothing is clipped, and I can just ship that directly to the user. So this is it. This is the couple of new features we've been working on. There's a ton more things that are going to come. So yeah, stay tuned. Thank you. So I don't know if we have time for questions. OK, we have time for a couple of questions. So if I can bring my other friends there.
For the list preview on the list view item, right here, Jeremy, right here.
Where am I? Oh, there. Hey.
For the list preview, you know, I guess you guys did that from Eclipse, where you can preview like a list. Yep. Is there a way to specify how many elements you can put in there?
We can probably, yeah, I think I'm going to add essentially a property on that same design panel so that you can customize even more those kind of things. Yeah, that's totally the plan.
So quick question about navigating to layout files. Have you done anything to make that easier from like where it's referenced in the code, for example?
We actually filled the line.
This is actually, yeah, this is part, so I haven't showed that because I didn't have the time, but yeah, we're also adding a lot of new code side kind of feature from your C# code to kind of, yeah, interact better with your layout file, and this is one of them. So this is in the work.
What does logcat parse give you that the new profiler doesn't?
So the question was, what does logcat parse do that the profiler doesn't? The profiler, at this point in time, does not actually record or track the number of grefs that are created or what the count is now or at a given point in time. That is something we'd like to add, but it is not present now. And as such, it is somewhat difficult to realize. I mean, in the profiler, in this case, you would see, all right, we allocated X drawable buttons. But at present, you wouldn't know that some of them might have already been collected. You would just know that over the lifetime of the application or for the time period you're looking at, you allocated 20 buttons or images or whatever. So with logcat parse, you'll know the exact number of drawables or what have you at a given point in time. But yeah, the profiler should be extended for the same behavior, but time constraints.
Last question. Can we see all the stuff in the new profiler that Mikhail presented earlier?
Pardon?
Can we see all this stuff from logcat parser in the new profiler that Miguel presented?
That was the previous question.
Yes,
it gives a slightly different view of things.
But I think the idea is to have this kind of view in the profiler to integrate it. So I mean, this is where we're going.
That's something we would like to do in the future that is not there now.
All right, thank you so much.
Thank you.
Folks.